Hello everyone. Today I want to explain about application of differentiation in real life engineering. I'm from Group B and my group member is Kirtiraj. Firstly, we have to know about differentiation. Differentiation allows us to find rates of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. Differentiation is used to measure the change in one variable that is dependent with respect to per unit change in another variable that is independent. Lastly, is differentiation is also used to get the slope of tangent in graphs, including determining the maximum or minimum point of curve graphs. This is the graph, distance time graph that is used to find rate of change, uh, rate of change of the time. So this the x-axis is t and y-axis is ft. That is s. S, what is s? S is distance. Then t is time. So this is the graph. The below is illustration derivative as slope of a tangent. So this is graph of fx respect to x. Graph of x respect to fx. So this is the graph. This is the tangent at P. This is the chord PQ. The graph fx, and this is the graph fx. I will give Prithviraj to explain about differentiation and integration. Then the Newton's law of cooling.
A very good day, everyone. My name is Kita Chankeswar. So today I'm going to talk more about differentiation, which is differentiation of a function. An example is shown on the left of the picture where y equals to ax power of n, and when differentiate is a n x power n minus 1. For example, is 2x power of 3 differentiated, will become 6x squared. And we have 6 rules, which are rule 1, which is constant multiplication rule. Rule 2 is sum rule. Rule 3 is the product rule. Rule 4 is the quotient rule. Rule 5 is the composite function or chain rule. And rule 6 is the inverse function rule. The integration is the reverse of the differentiation. If a gradient of a function curve is dy dx, g equals to g inverse x. Therefore, is y equals to the integration of gx. So now is the Newton's law of the cooling. It's an example of the differentiation that is applied in the real life engineering application. It states that the rate of temperature of the body is proportional to the difference between the temperature of the body and that of the surrounding medium. The equation is presented as dt over d over time, temperature over time, equals to negative k bracket t minus t naught, which is t. This t is the temperature of the object. This is the surrounding temperature. And then we delete the t on the left hand side, we get dt, and then we divide it by t minus ts, we get finally, which is 1 over t minus over ts, the dt equals to negative k dt, and then we integrate both sides. We get ln t minus ds equals to negative kt plus c, and then we exponent both sides, and finally we get t of a time of t function of a time equals to ce negative kt plus ts. Finally, applying the condition, we get at t0, we get c equals to t naught minus t surrounding. And the final one, substituting the value of c from equation 2, we get t equals to t naught plus t naught minus t surrounding equals to e power of e negative kt. And the t is the temperature at time, the ambient ts is the ambient temperature, k is the positive constant, and t is the time. And that's all for me. Thank you.
So the other application of differentiation in engineering field, firstly is cars. A car doesn't leave from the factory without knowing where the center of its mass and weight and central exists to determine the factors of security and safety on different roads and different speeds of the car. Then it is used in designing. The graphic engineer use calculus to determine the difference and change of three-dimensional models and how it will change when exposed to multiple conditions. This helps him to create a very realistic environment in 3D movies or video games. Then in space, space engineers often use calculus when planning long missions to launch a probe because they need different speeds in the probe's orbit proportional to gravity and altitude. Calculus helps them to determine all these variables with infinite accuracy. The structural analysis, they use calculus to create earthquake-proof structures that can withstand any level of earthquake tremors. Lastly is frictional force used in mechanical engineering computing the surface area of complex objects to determine frictional force. So the conclusions of this topic is differentiation and integration has many applications in real life, especially in engineering, and basic calculus knowledge is important in finding solutions for engineers. That is from my group, uh, Prithviraj and I, Norman Amirul. Thank you.